All right, now is the ultimate event that happens after the embryo becomes a trilaminar disc, is that we have to get this trilaminar disc-shaped embryo to be a cylinder that actually has some 3D shape to it, because the embryo, doesn't develop into a pancake-shaped baby, but actually develops into a three-dimensional embryo and eventually into a fetus that is round and is containing fluids and organs and everything. So we have to get from here to here. How does that happen? Well, we have folding of this embryonic plate that happens in two different planes. So the first one I'm going to talk to you about is folding in a median plane, which means if you were to lay on your back as a flat embryonic disc, and then you were going to do a sit-up and pull yourself forward, but also pull your legs up and touch your toes at the same time. That's folding your body in the median plane. So we're going to talk about what happens in this plane first. So this is what we start with, and then this is what we finish with here. And so if we look at just specifically the head region or the cranial region of the embryo, this is what we start with. We have a trilaminar disc, we have ectoderm, mesoderm, endoderm, and we have this cardiogenic region that is going to develop into the heart and associated blood vessels. And then we have the oropharyngeal membrane that is going to develop into the mouth region, the foregut, beginning of it. And so all this is continuous with the amnion and the wall of the umbilical vesicle. So the developing neural tube and brain grows really fast and a lot faster than the other aspects of these structures here, and is going to project outward and fold ventrally. So you can see that this what was here is now going to be on the other side, and all of this stuff gets tucked under because this is growing faster. The neural tube is growing faster than this tissue that is in this area here. And so that is going to reposition the heart and the septum transversum, which is tissue here that separates eventually separates the pleural and the abdominal cavities. And in the gut, so the brain is going to actually, the developing brain here is going to come up and eventually be more superior than the heart and the gut and all of these structures here. So that makes sense, right? Because your heart is actually lower than your brain, and this is how that happens, is we call this the head fold. And then as it folds around, you can see that all of this region here gets tucked into the embryo. So it actually incorporates some of this gut umbilical vesicle into the embryo. We're going to call that area the foregut. So that's sort of going to be the beginning of the gut. And you can see how that oropharyngeal membrane will be the most superior aspect of this gut region. So this all starts as this head folds around. And so after that folding happens, you can see how the septum transversum, so here you have the pericardial where the pleural cavities will develop into, and here you're going to have this abdominal region. The septum transversum is sort of this block of tissue here that's going to separate the two. The heart is now under or more inferior to the brain. Here you have the gut tube folded into and incorporated into the embryo instead of just being stuck out on the ventral side. So all of this is going to assist and participate in the development, further development of these organ systems and the cavities. And this similar thing happens in the tail or caudal region of the embryo. And so we're going to have very rapid proliferation and development of this neural tube on the caudal end. And it's going to cause this aspect of the embryo to grow farther and quicker and sort of whip around on the ventral side. And at the same token, it's going to incorporate this part of the gut into the embryo instead of being just stuck out at the bottom. And so because of this happening, this is called the tail fold. We have the hindgut, the ending aspect of the gut, and we know this was supposed to be the anus. So this gets incorporated or develops into the anus. It gets incorporated into the embryo, and the umbilical stalk gets incorporated higher up and on the ventral side of the embryo, and this will become the umbilical cord. So, the umbilical cord is usually in the navel region of the baby. When the newborn is born, it's usually not stuck out at the bottom between the feet or on the tail side. So this is how that happens, and we call this the tail fold. Okay, and so, and you can see how the gut gets incorporated there. And after the gut gets incorporated, this aspect of the hind gut is going to dilate and form a structure called the cloaca, which will further develop into both the bladder and the rectum, and those things are going to be sectioned off from each other, and you'll learn about that when we do the gut development and the urinary system. Okay, and I talked about the connecting stop being incorporated on the ventral aspect. All right, and so that's how folding of the median plane happens, head fold and tail fold. Now let's think about folding in the horizontal plane. So if you were to lay on your back as a flat embryo, and you are going to bring your, put your hands out side by side of you with the palms up, and then you're going to bring your palms together and put your hands together. That's folding in the horizontal plane. So we're going to have those edges of the embryo are going to come around, and they're going to come together on the ventral side, and they're going to fuse in the midline of the embryo. So this is what we're starting with. Here we have the two different aspects of mesoderm, lateral mesoderm. And so here we have the somatopleur, it's in this region here, and this is a splanchnopleur. And this part of the embryo is going to come forward like this, and come forward like this in a horizontal plane, and it's going to meet in the midline. And it doesn't fuse everywhere right away, but one of the important things that happens as this occurs is that it incorporates this big umbilical vesicle into the embryo, which will develop into the midgut eventually. And this actually has a really cool path of development, which you'll learn when we do gut development. And so before, you could see that we had a very big communication here between the midgut and the umbilical vesicle, so it was very big communication. And then as these folds come together, it really pinches it down. So now we have this little tiny communication, and that communication is called the fallow-enteric duct. Not hugely important function-wise, but you'll see that in figures. You might wonder why we haven't mentioned it. So really, that's just the leftover communication between the umbilical vesicle and that midgut that got incorporated into the embryo. And so for me, learning development, and no one had pointed out to me, it took me a long time to realize that this folding and bringing down of the walls of the embryo in this horizontal plane is how the amnion gets incorporated all the way around the embryo, and it doesn't just stick out on the dorsal side. And so because you actually have the amnion attached to now it's all the way around, you can actually have an amniotic sac that the embryo is floating in and developing in. And before, it was just sticking out on the dorsal side. So this is how that occurs through this horizontal folding of the embryo. And I'll link this in your module so that you can watch this YouTube video of the folding of the embryo. It's a pretty good, cool animation.